Hello, so what I'm going to be showing you now is how we can transfer the AdonisFX rig setup from one DCC to another. In this case, we're going to go from Maya to Houdini, do some tweaks, and then bring the settings back inside of Maya. So here we have the different layers being simulated inside of Maya. So here we have the muscles, for example. Then we have the fascia. We have the fat layer. We have the skin layer. And then we have finally the rendered skin layer, which brings it back together with the animation. Great. So now what we can do is we can come to the AdonisFX menu, press export. We can select the layers that we want to export. In this case, we want to export everything. And then we are just going to rename this file and press export. So now we'll dump out a JSON file with the information of the rig. With the different AdonisFX settings, and now we can come back into Houdini, and here we have already prepared some data. So we have here also the joints, so the skeletal joints, which will drive the animation. So for example, here we also have the mummy geometry. Let me put this to smooth shaded. So here we have the mummy, which is essentially animated. Then we have the anim skin, which comes also from Maya. Then we have the fascia, which is static, the fat that is static, the skin that is static, and the rendered skin that is static. Then finally, we have the muscle geometry right here. And very important is that we maintain a path attribute that we can use for the importing. So in this case, this has to match the exact same name that we have inside of Maya. That was used to create all of those deformers. In the case that we do not have this attribute, we can come here to AdonisFX utils, create muscle piece ID, and it will create a path attribute for us. But in this case, what we want to do is that each entity has to be separated. So we can click on separate geometries, and it will separate each muscle individually because that's a requirement that we need for AdonisFX to work. Great, so now we have all of this information. We can come to the AdonisFX menu, press import, and we are going to import this JSON file that we just generated in Maya. So I'm going to press import, and now it's going to take some seconds to import all of those nodes, all of the settings, all of the paintable maps, and then we will be able to see this simulated live inside of Houdini. I'm also going to give a brief introduction of like the naming conventions of the different regions, because that's what we need to then transfer the data back inside of Maya. So yeah, there we just have some logs telling us which were the connections that couldn't be made and the ones that succeeded. And yeah, here we have the setup. So actually, let me bring this subnetwork up here. So here we would have the muscles coming in. So for example, here we have the abdominis muscle. And as you can see here, the different shapes or the different geometries that are being affected have to be encapsulated in two null nodes, ADN in and ADN out, which will tell the system that this region is affecting essentially the deformation of this specific shape or geometry. So now we can check all of these muscles, which are going to be merged here. Here you can see this being simulated. What we can also do is, let me just use the gravity inversion here, which is just to align the gravity pre-roll with what we have in Maya. So that's now inverted. And now I can play this back. And you can see that we are simulating those muscles inside of Houdini. And we can go through the different layers, going from left to right. For example, here we have the glue muscles. You can see here if I enable the debugger. So here we have the glue constraints. You can see all of those constraints between those muscles. And yeah, we can go, for example, to the fascia geometry right here. And yeah, you can see that it's being simulated. Can go to the fat layer, can jump in time. You can see that the system converges. And let me actually hide the other objects. And yeah, and then finally we can come to the final layer, which is the rendered skin, which essentially brings everything together with the animated skin. Let's jump in time. You can see that the system will recover from the time jump that I did in the frame range. Great. So another thing to consider is that the maps will be ingested by the stash node, will be copied on the original stream of data. And then you can also visualize the different targets by coming to view, show all nodes, and it will tell us like how the connections are being made between different entities. So let's turn this off. And yeah, we also have here on the other side, we have the sensor and locator setup that will drive the activations of the muscles. Great. So for just the purpose of this demonstration, I've cached out the simulation of this character. So you can see here, this would be the simulation, and then we can use different components, like for example, a vellum simulation on top to enhance the results. So here you can see we are bringing the belt, like a belt simulation, and then applying some materials, some very simple materials, we can get something like this. So let me play this back once. Yep. So yeah, then we can layer different tools and simulation from Houdini on top. But what if the TD wants to do some changes inside of Houdini and then see the results back in Maya? So for example, let's say that we want to come to the triceps. This left tricep here, going to cook this. And what we're going to do is we are just going to remove the material because that's cleaner for the painting. So let's use here the primitive attributes. Let's remove this. And then each muscle entity has the ability to add paintable attributes. So if we select the node and we come here to use make paintable, we can make this specific node paintable. And if we come to the attribute paint node, we can then paint different maps here. So for example, we're going to use the attachment to geoconstraints map, increase the radius, and yeah, what we're going to do is just use a value of 0.1. And we are just going to paint this area right here to reduce the attachment weights. So let's come back to the simulation. And you will see that, yeah, the muscle is a lot looser. In some cases, yeah, we would have to do a better job at the painting. But yeah, essentially, we are going to reduce the weight painting, and this will allow the attachments to be a lot looser. Great. So now we have modified the setup inside of Houdini. But yeah, we of course want to see the results maybe also in Maya. So what we can do is we can press export here, and we can come to just selecting the muscles because that's the only thing that we have modified now. And we can come back to the export options, and let's say from Houdini. Okay, now we press export, and that will just export the muscle setup. Then we can come back inside of Maya, and now we can come here to import, and the system already knows that just the muscles were exported, so we can come here and we can press import. Great. So let's give it a second, and now we can come to custom here. I'm just going to do a custom pre-roll setup. So shot specific data. And yes, now if we come and have a look to the back and play this back, we should see that this tricep is more looser than the right one. So yeah, you can see there the tricep moving more freely compared to the one on the right. And yeah, we can also, if we wanted to, just hide this layer, come to the muscles, come to AdonisFX, and yeah, you can see right here that this value has been picked up from Houdini with the value of 0.1, and yeah, that demonstrates that we have brought the data back into Maya correctly. So yeah, that's how you can transfer one setup to the other between the DCCs, and we have to just make sure that the naming is correct, that the different attributes that we have inside of Houdini will work. Generally, what is the path attribute that we will use, which is something that you can create on the fly also with some notes. Great, thank you, bye bye.